Yeah, so this is a conversation to what we did is we launched a little question to all of the people following AVNR. Just what questions do you have for us? So I've got David here, and we're going to have a conversation and look to try and answer some of those questions, and hopefully we make this interesting and fun. My name's Michael. I head up the sales team and the product development team here at AVNR.
And my name is David. I'm head of all the robotic finishing and development team. So making everything we can so that we have a wider and wider offer in robotic finishing.
Next question is, what are our main expertise? So robotic finishing, David, why don't you cover it?
Right. So our main expertise when it comes to robotic finishing. So we have a profiling, which mostly applies on airfoils. So it covers leading and trailing edges, aerodynamic profiles. We do polishing, different surfaces. We also have tri-blending, which is also specific to airfoil or blades. We have also a process which we call pin blending, where you want to remove a specific and specific amount of material that is on a surface. It can also be applied on MRO parts, where there's material added to repair the parts. So in this case, we would think about or call it edge blending. And we can also cover deburring processes. So basically, we want to be this one-stop shop for all what's related to finishing the parts. In aerospace market, that's true. But then also, as you mentioned, Mike, we're starting to open up this medical field as well. So that's where other applications are for polishing, amongst other processes.
When we come and help customers, that we talk the same language as them, and so we talk a lot about the aerospace. Now we're talking about orthopedic. One of the questions that I've been getting more and more interest around is reconfigurable systems. So you touched a lot of the like a lot of finishing processes that are pretty common amongst a lot of industries and in manufacturing. Do you see our systems as being reconfigurable to tackle a wide variety of problems?
That's a good question. Actually, the way we push our development is we try to be as much modular as possible. So it covers not only reconfigurable systems, but scalable systems as well, right? So you want to develop your technology so that you can apply it on different markets, but so that you can also combine them easily. Mm-hmm. So you want to think about Lego blocks, right? You want to put in more or less equipment to be able to achieve more or less processes or different processes. And not only different processes, but you want to be able to attack or accommodate different markets as well with different needs. Mm-hmm. So in that sense, I'd say, we're not only configurable, but modular, so that we can be scalable as well. Mm-hmm. And that brings us also to the point where we can cover smaller parts, but with similar design that we scale up or scale down. We can cover different size of parts that could be similar or not.
Sure. So if the part fits in your hand and you're polishing it, we could probably fit it inside of a 200C and do a really good job of tackling that type of job.
Yes, and we talk about scaling, about modular blocks, but we can also talk about different approaches. And there's a lot of different reasons why you would hold the part or hold the tools. And there are different reasons why you're going to choose one or the other configuration. But we also have different ways accommodating this, right?
Yeah.
So
Yeah.
those are all modular blocks that we want to develop and be able to integrate in different manners. Now, of course, you talked about specific configurations of system or sizes of systems, right? We have product lines, and we have specific products that are already maybe designed or set up, but then we can play with this quite easily.
So you talked a lot about the robotic finishing side. On the visual inspection side, the way we first started getting into the visual inspection, and what we mean by that is any defects that are on the surface of the part. So I have a mouse here. If I had to look at this mouse and look for any scratches, nicks, dings, missed operations on this part, that's what we really target for visual inspection. Now we're kind of going full circle, because when we first started, somebody came to us and asked, well, I need to measure certain features on the part. And we said, okay, great. And we put together a solution. We said, by the way, do you have to look at the surface? Are you looking for scratches? And that was, I think, probably 12 years ago. And we went on this track where we specialized in surface inspection. Now, what I see us doing, and this overlaps with the robotic finishing, we're integrating a lot more of the feature measurements back into our systems. So whether we're getting into adaptive processes for robotic finishing or adding on additional capabilities to our inspection stations, I see that as a trend that will continue as we go forward on the visual inspection side.
Well, actually, you talked about visual inspection. I previously talked about robotic finishing. We have to mention that we now combine both technical solutions, right? And we get to have this development where we do inspection, communicate information about the defects so that we can repair those defects. So this is really an interesting combination of our two strengths that are being put together to open up really whole lot of different opportunities, to improve manufacturing in general.
Yeah, that was a topic we were supposed to present at the Innovation Week with Aero Montreal, was the inspect and repair in our partnership project with through the Aerospace Research Organization, the CREAC. Unfortunately, it got canceled, but I see a lot of potential in that in the MRO and the repair and overhaul, where there's a lot of spot repairs on a lot of these critical parts. And so what I see as your team doing with the visual inspection team, combining the two technologies together is pretty incredible. So on what parts are our systems operating?
Well, we mentioned different markets and areas. So mostly aerospace. We're getting really good at tackling the blades, vanes, either turbine or compressor blades. So critical rotating parts, even touching discs, shafts. We've touched combustion chamber, and then we can go all the way to casings or even lip skins. We've worked on lip skins as well. So really all what's in a aerospace engine, even energy engines, so energy turbines, sorry. And as you mentioned, we started working on medical implants, mainly knees and hips.
Have you seen a commonality between going from aerospace to medical, and did you find a pattern that jumping between the two?
And surface finish, we start to see like more and more of those really shiny surfaces in the aerospace industry, whereas in the medical industry, there's a lot of this those shiny surfaces. So there's a similarity in that sense in between both both type of parts.
So the next one we're going into, we've been talking a lot about robotic finishing. The next one is, what is the main difference between AV&R and other camera integrators or manufacturers of smart cameras? So the way that I look at this, we're not just providing a camera. So, and I'll make an analogy to the robotic finishing. So when I sit down at the table with a customer and we start talking about what they get into, everything revolves around the process. So they're trying to polish a part and they're trying to create a certain surface finish. The inspection, we're tackling the same type of thing. It's really a process. So it's not just a camera that someone is using. There's a few layers to that process that we have to get into. So imagine you're holding this part apart and you're trying to inspect it. Well, first you're manipulating it around and you're trying to have the light reflect off of it so that it comes back to your eyes and you can see it. So there's the imaging of the part itself. Then your eyes are looking at it and they're detecting certain things. So there's maybe some filtering or some image processing that goes on. And then after you're able to extract the defect from there, you have the classification of it. So depending on where on that part that defect is, you might make a different decision about it. So you want to classify and identify where is that defect on your part, and you set a threshold based upon that. So all those steps in determining, is this a good part or not, that's something that we work with our customers and kind of put into our systems. So again, like we were saying before, hopefully these systems are simple to set up and run, but there's a few layers to them. What is the purpose of our software, in brackets, Brainwave? So David, I'll let you take a run at this.
Well, just to link it with the previous subject, we talked about having complex things getting done in a more simpler way, or appearing to be simple, right? Well, the software is one key thing for that purpose. So our software our software purpose is to control the robotic cell. So it makes you able to run the robotic cell, and its purpose is also to be able to do some offline programming, because you don't want to be stopping the system to program new or introduce new parts or modify some programming. So you can also use the software to program offline. So now on the operating portion of the not portion, but from the system operating point of view, we want it to be simple to use, really graphical, and ready for data collection and data displaying, so that you can understand what's happening in your system. And on the offline programming portion, then we have different ways of offline programming, and there are different steps in terms of offline programming. There's an initial step where you do the initial path programming. So there are more and more tools here and there to program. So the advantage of our system or our software is that we really focus on our specific needs, so we can push really hard on specific tools for the specific processes we are developing. So the tools are really well oriented on our needs, or the needs of our clients. Actually, I should say it's really oriented based on needs of our clients, so that we have easy ways of creating and adjusting initial trajectories and setting some initial parameters, such as force control parameters, speeds, tool speeds. So different parameters that we can adjust. And then we have a second portion to the teaching, which is kind of somehow offline, but you also need some, to try on some parts to have some feedback on how the system reacts. And then you can have different ways of collecting data on the part, such as, one of the great and important data you want to collect is the force that is really applied on the part. So you can also collect this information and modify your programming so that it's done. It gives you the expected results really quickly. And so with that being done, you can have your recipe. So you can have a recipe, version controlled, etc., and with some data to keep an history of what has been done. And yeah, that's it. And then you have this. You can operate with the same software, same interface. So that's really an easy transition in the different steps of getting a recipe from zero to our running condition. And then even more, so when it's running, not only like have the parts run, but you want to collect also data on what happens, and you want to have some tracking. So that's something that we are offering.
And the one thing that I found encouraging, that kind of says that what the software combination you guys put together, and we're on the right track, is when I start to see customers that have been using our systems start to become better than us at tuning them and trying new things. So now I'm starting to see customers come back and they're actually innovating on process with our systems. So one customer, when she described our system to us, she goes, it's not a robotic system anymore. It's really a process system. And the way we can control the process is very tightly integrated into Brainwave. So more and more, I'm starting to see, my favorite stories are when, let's say you've come up with a new blending process, and maybe there's a weld repair that customers asked us for before, and we finally have gotten around to trying it. And so when I've talked to customers, they said, well, that's nice, you guys finally did it, but a couple of months ago, we put that in our system, and actually we were able to achieve really good results. Yeah. So I really love seeing that our customers have been able to understand what we've done and then take it to the next level, because at the end of the day, they own the parts, and they're able to innovate. So if we're enabling that, we're doing something right.
Yeah, and to me, it sounds like success, because it means our tools are easy to use by clients, right?
Yeah.
So absolutely. That's like mission accomplished. We still, we never take anything for granted. So we're still working hard on this, but that's a really good thing. And one of the things that really helps some clients using our system is that we have now the capability of visualizing robotic cell straight within Brainwave. Of course, you can still use the Fanuc simulation software, which can be connected to Brainwave seamlessly. Yeah, but you still have visualization capability built in Brainwave, so that you can do some previous simulation, and it's really quick to see it's really quick to see if there are any collisions or path that can't be performed because of singularity or any other problems. So yeah, so that makes it easier for clients to use. And as you mentioned, what happened, this phenomenon that you were talking about, we want it to happen more and more. I mean, it means the client it's easy for them to use our system, yes, but then we can also learn and have feedback from them to improve those different methods. So yeah, no, that's really good news.
So the next question is, what technology or what solutions are you currently developing?
Yeah, I guess I'll get to this one because it's really in my field. So we just talked about the software. So as for the software, we are now gathering some data, but it's at the basic level. So we want to bring this to next level where more and more data will be available, recorded and available, not only to ensure traceability, but you talked about AI, and we want to also be able to gather data for eventually adding up some artificial intelligence mechanism in there. So there are different ways of implementing AI in systems, right? So according to what you need to do. So that's where we want to go, and we're really well engaged in that path. So that's one development portion. So we want to be offering like improved capabilities in terms of downtime planning, optimizing those downtime. Those are really key things. And then optimizing, help a client optimize their production, offer different tools, you know, to be able to correlate some data, to take better decision, and eventually take those decisions, or suggest the decision to take. So that's on the software portion. So really that's going to be something really interesting in the future to be watching for. Other than that, we're pushing on different technologies. So we've been working on with feedback device for a while, using them really for the process purpose. We want to be pushing on using this feedback device to give more information about the results we have on the part, specifically dimensional results. This is what's mostly critical on part. So yeah, so that's really something we want to be pushing hard on. We talked about the combination of inspection and repair, and that what I'm talking about is bringing it to a next level where we can, you know, validate the result in terms of dimension right within the system, you know, so that's all integrated. So in other words, we want to be at some point replacing some CMM inspection, you know. So that's something we are really working on. And other than that, we're pushing different technology, different processes, sorry, as well. Looking for more and more processes in the medical device, medical market, for in terms of different areas we want to be tackling, polishing or deburring. We're also thinking about expanding on the autonomous robot side. So this is something that's further in the future, but we want to be offering, you know, this capability in the future as well.
Yeah.
So those are really huge subject we're tackling, you know, bit by bit, but those are interesting markets we want to be in as well.
Yeah, and I think that last one that the autonomous robots, for many years it's been our vision to help our customers, you know, any hand finishing process that is giving them, you know, like creating quality issues, or anytime someone touches the part and maybe there's a reason to look to automate it, whether it's the new tolerances. We have this vision to be manufacturing facilities where that's completely hands off. And as we systematically tackle all of these hand finishing operations, we're getting really close to seeing that as a reality. And then with some of the new robotics that have come out and are starting to take shape with the collaborative robots and the autonomous robots, I can see a day now where there'll be flexible manufacturing spaces, very resilient manufacturing spaces, without having the need to put up a lot of fences and a lot of barriers to getting the job done.